In today's lesson, we're going to look at another circle theorem, which is the angles in the same segment are congruent, are the same size. Okay, before we start though, I'd just like to show you some important words that we use for circles. So I've just drawn a line that goes from one side of the circle to the other. Now it isn't going through the center, so if it was, that would be a diameter. But this is cutting the circle into two, and this is called a chord. And what it creates is two segments. So this segment here is the minor segment, and the other region is the major segment. So this here is a segment. Okay, so here we've got an angle. Let's say this angle was 30 degrees. Now, what I want us to do is to think that this angle is making that chord there. Now, another way of thinking of it is that it's making this segment here. So I'm going to create the same chord or the same segment over here. Okay, so can you see that this angle is creating the same chord that this angle had created? So this angle had created the chord originally, and as a result we can say that those two angles have the same size. So the circle theorem is angles in the same segment. So this is the same segment, and it could have been created by either of those two angles. Those two angles are the same. So we could do it again. We could have the same segment created by that angle over there, and that would also be 30 degrees. Okay, so here we have the first question. We've been asked to find the size of angle x. Now the thing to look at is this angle here. This is 55 degrees, and it has created this chord or this segment. But this segment can be created by this angle here. So angle x is also 55 degrees. Okay, so we have two angles. We've got the 30-degree angle and we've got the 40-degree angle. Let's have a look at the 30-degree angle. This 30-degree angle has created a circle segment with this chord here. So that chord there, or that segment, was created by a 30-degree angle. Now, has that been created elsewhere? Well, let's just look. Here's the chord, and we can see that that angle has created it. So that's also 30 degrees. So V is equal to 30 degrees. Now let's have a look at this 40-degree. I'm just going to put 30 degrees in there. This 40-degree angle here has created this chord and therefore this line segment. So this circle segment there. Has that circle segment been created elsewhere also? Well, yes it has. If we were to come down to here, that chord could be created there. So this segment could also be created by U. So that's also 40 degrees. And let me just put that there. Okay, in order to find x, we can just use the triangle. Angles in a triangle add up to 180. We've got the 40 and the 30, which is 70. So x is going to be 110 degrees. And in a similar vein, for w, we've got 30 and 40. And so w again is 110 degrees. And we could have used the fact that these two angles are vertically opposite as well. Okay, here we've got angles on a straight line, and they must add up to 180, so x is going to be 60 degrees. So x is 60 degrees. Okay, now if you notice, this angle here has created this chord and therefore this circle segment. Could that circle segment have been created elsewhere? Well, it's here. Yes, we could have done it with this angle here, which is angle Y. So angle Y is also 60 degrees. Okay, the final question here. Now, if you notice, in this case, O is the center of the circle. So going back to the other circle theorem that we had before, if we look at this triangle, then we can see that this angle is actually 90 degrees because the angle's in a semicircle. The angle is 90 degrees. Okay, and that's going to be the same also if we look at this triangle here, and this is 90 degrees as well, so W plus X is going to be 90 degrees. Okay, however, the only angle we have at the moment is that of 50 degrees. So if that's 50 degrees, well, let's see what we have. That's created that chord there, i.e. that line segment. Could that that chord have been created elsewhere? Yes, it could. It's been created by U, so U is also 50 degrees. So let's just put that U is equal to 50 degrees there. Now, because we know that this angle is 90 degrees, 90 plus 50 is 140, we now know that W must be 40 degrees because the angles in a triangle add up to 180. So if W is 40 degrees, that then tells us that X must be 50 degrees because we know that that's a right angle there. If this is 50 and this is 90, 140, then V is 40 as well. Okay, so we, in order to find Y, we can use this triangle here. Angles in a triangle add up to 180. That's 40 and 40, which is 80. So Y must be 100. We could have also used the fact that these are two radii, therefore it is an isosceles triangle. And if Y is 100, Z must be 80 degrees because angles on a straight line add up to 180.